Hello, everybody, and welcome to my channel. This channel is specialized in solving FE civil exam problems. Today, I will solve several hydraulics and fluid mechanics problems. So let's start with problem number one. So a venturi meter with a throat diameter of 0.1 meter and an inlet a diameter of 0.2 measures pressure difference of 2000 Pascal. If the fluid is water, what is the flow rate? So a venturimeter is a device that calculates flow through pressure measurements. So it's something like this. Okay, this is a venturimeter. So we know the diameter, the inlet diameter here. So this is 0.1, 0.2 meter, 0.2 meter. Let's call it D1. So D1 equals 0.2 meter. And this is the throat. So D throat, D2 equals 0.1 meter. This is D2. And we have P1 here, the pressure. And we have P2, and we have delta P. We measured the pressure difference, 2000 Pascal. So by measuring the pressure, we want to determine the flow. So the question is, what is flow? What is Q? Now, this is a very common type of problem in FE exams. So whenever you have a venturimeter, whether it asks about flow or other unknown, so we use Bernoulli equation. So we can apply Bernoulli equation between sections 1 and 2. So this is section 1, and this is section 2. So we apply Bernoulli equation, assuming that the venturimeter is horizontal. So we have P1, Z1 plus P1 over gamma plus V1 square over 2G equals Z2 plus P2 over gamma plus P2 square over 2G. So this is Bernoulli equation. Now, we try to simplify this equation. So we have Z1 equals Z2. So we can cancel from both sides, Z1 and Z2. So we will be left with P1 and P2, which are known, and V1 and V2. Now V1 equals V1 equals V1 equals Q over A1, and V2 equals Q over A2. Now we go back to the equation, to Bernoulli equation. So we are left with P1 over gamma minus P2. I am rearranging the equation, minus P2 over gamma equals P1 minus P2 equals 1 over 2G. I will take 1 over 2G out, and I have V2 square minus V1 square. V2 square minus V1 square. So now this is the equation we have. Now if we substitute, now here from the left-hand side, I can take 1 over gamma out. I will now only do math. Okay, this is the how we converted the information to an equation. Now I will do the math. I will simplify the equation, plug in the numbers, and get the final answer for Q. Now P1 I can take from the left-hand side, 1 over gamma. Then I have P1 minus P2, and I have here 1 over 2G, and B2 square is Q square over A2 square minus Q square over A1 square. Now, I can bring the 2G here. So we have 2G over rho into P1 minus P2, which is known, equals, I can take a Q square out, which is the unknown, and 1 over A square, A2 square, minus 1 over A1 square. Now I know A1, the diameters are known, so A1 is A1 equals by D square by D1 square over 4, which is by D1 is 0.2 square over 4, and A2 equals by D2 square over 4, which is by 0.1 square over 4. So I have E1, A1, and A2. A1 is known, A2 is known. Now I can plug into this equation. I know P1 minus P2 is 2000. I know A1 and A2. I know these are knowns. G and rho are known. G is 9.81 and rho is 1000. So the only unknown is Q. So if you do the math, you will get Q equals you solve, you will get Q equals 0.016 meter cube per second. So this is the solution to the problem. So we go back to our question to select the correct answer. So the correct answer is C. The correct answer is C, 0.016 meter cube per second. So this is very common type of a question in the FE exam about the dimension meter. Now for the venturimeter, or you always apply Bernoulli equation. Okay, the next question is an open channel question. So we have an open channel. Let me remove these. We have an open channel. Rectangular cross-section. This is the rectangular cross-section. Rectangular cross-section. B equals, the width is 4 meters. And the water depth is 2 meters. And we know N equals Mani roughness coefficient is 0.015. This is known. And we know the slope of the channel is 0.0005. These are known. Now for Mani equation, now it is required to determine the flow. What is the flow rate? U. What is U? Now for Mani equation, for open channel, we always use Mani equation. If we are given the cross-section characteristics, we are given the N and the slope, then we will use Mani equation to determine the flow. Very straightforward application. So in Mani equation, we have to find the area, the cross-sectional area, and we have to find also the R, the hydraulic radius. So we calculate the cross-sectional properties. A equals, the area is 2 by 4, the simple cross-section, rectangular, so it is 8 meters square. Now R, which is the hydraulic radius, R equals A over P. P is the weighted parameter, so we have to calculate P, which is 4 plus 2 plus 2. So it is 4 plus 2 plus 2, which is 8 meter. Then R equals A over P, which is 8 over 8, which is 1 meter. Okay, so now we know the area, we know the R, we know the Mani coefficient, and we know the slope. So we can apply Mani equation to determine the flow. So let's apply Mani equation. Okay, let me remove this. So Mani equation, Q equals 1 over N A R to the 2/3 S to the 1/2. This is S. Slope, slope to the 2.5 to the 0.5. Okay, slope to 1/2. Okay, this here. Sorry. So S to the 1/2. It's here. So this is Mani equation. Now this in Mani equation, if the units are metric, so use the constant is 1, which is our case here. If it is feet, the constant is 1.49. So we have metric equation, metric units here. So we use 1. So now we simply plug in the numbers, 1 over 0.015 by the area is 8 meters square, R is 1 to the 2/3, and S is 0.000. 5 to the 1/2. So if you do the math, you will get Q equals 11.92 meter cube per second. 11.92 meter cube per second. So this is the solution to the problem. It's direct application on Mani equation. So the correct answer is A. The next question. Okay, it's about a hydrograph. So we have a triangular hydrograph, and we want to determine the total runoff, the volume of the total runoff. Again, let me remove these. So we have a rectangular hydrograph. It's something like this. Hydrograph is the relationship between time and runoff. So this is runoff, and this is time. The x-axis is the time, and the y-axis is Q. So the hydrograph is triangular, so it's something like that. And the total duration is 12 hours. So we have the peak flow, which was 10 meter cube per second. Here we have 10 meter cube per second, Q peak, 10 meter cube per second. And the duration of the storm is 12 hours. 12 hours. So it is required to determine the total volume of runoff. So the total volume of runoff is the area under the hydrograph. So the hydrograph is triangular. So the area equals, so total runoff Q, or let's call it V. Q is meter cube per time. V is meter cube. So we simply multiplied, we determine the area, which is 12 half by 12, and we have to take care of the units. So this is in hour. Let me do it, have more space. So remove this. So the area under the hydrograph A equals half by the base, which is 12 hour by 12 hour, okay, by the peak flow, which is 10 meter cube per second. Okay, that's all. The base, have the base by 10. Now we have to do unit conversion. So we have to change the hours into seconds. So by 3,600 seconds per second per hour. Okay. So this is duration is 12 hours, and this is 10 meter cube per second. So that's it. So we will have area, which is the volume. Area is the volume. So we have the volume equals the runoff is 216 1,000 meter cube. 216,000 meter cube. So this is a simple problem, but it also, this is one type of a question that occurs in the FE exam. So the total volume is the area under the hydrograph, but you have to take care of the units. So the next question, I want to do actually one more open channel question, but it is different type of a question so that you don't confuse the, let's see the question. So we have, again, a rectangular open channel. This question, 51. We have a rectangular open channel. The width is 2 meters. This is not the scale. Okay, let me go down a little. So we have a rectangular cross section like this. The width is 2 meters. This is 2 meters. And the water depth is 1.5 meters. And we know that the 2 meters, and we know the velocity is 2 meters per second. And we want to determine the flow. Now, when you know the cross section and you know the velocity, so simply Q equals VA. That's it. If we know the velocity and we know the cross section, the flow is QA. It does not have to do with many equations. Okay, this is different from the other or the problem we solved earlier. So if the velocity is known and the area is known, we simply multiply V by A. So Q equals V is 2 meters per second, and you have always to look for the units. Make sure that the units are consistent. So we have 2 meters per second, and we have the area is 2 by 1.5 by 2 by 1.5, and that gives us Q equals 6 meter cube per second. So that's all. That's it. So Q equals 6 meter cube per second. So the correct answer is C. Okay, let me check one more question. I will leave this to the other video. Okay, let me do this one. A submerged about hydrostatic force. So there's a submerged gate underwater. So we have, this is water surface. We have a water surface. And we have a submerged gate like this. Now we know the gate is 2 meters wide. B equals, the width is 2 meters. And the length of, no, okay. And the length of the gate is, B is 2 meters. Here, B equals 2 meters wide and 3 meters tall. H is 3 meters, which is this distance. 3 meters, this is H. H is 3 meters. And we know that the top of the gate is 4 meters from the water surface. So this is 4 meters. Yes, 4 meters. And we want to determine the force on the gate. Now, the easiest way To calculate the force, the hydrostatic force is F equals P multiplied by the area of the gate. Now, P is the pressure at the geometric centroid of the object, at the geometric centroid of the gate. So now this is vertical, so the centroid is at h/2. So we want to determine the pressure here at this distance. This distance from here to here is 1.5, and the gate is 4 meters above the water. So the entire distance is 5.5, 5, which is 4 plus 1.5. So P, we know that P equals gamma H, not this H, okay? So P equals gamma H, where H is measured from the water surface. So P, average P is 9,810. Is 9,810 or 9.81 kilonewton by 5.5. This is the average pressure. So the force is the average pressure multiplied by the area. So the force is 9.81 by 5.5 by the area of the gate, which is rectangular gate 2 by 3 by 2 by 3. So the force equals, if you do the calculations, so the force equals so F equals 323.73 kilonewton, 323.73 kilonewton. This is also a common question in the FE exam. So the easiest way to solve is to calculate the average pressure at the geometric centroid and multiply it by the area. So this is the fastest and easiest way to solve this type of problem. If you have any question about the problem solved in this video, please leave me a comment. If you have any problem you want me to address in future videos, please also leave me a comment. Thank you for watching my channel, and I look forward to seeing you in the next videos.